Okay, I apologize if you're an open source person, this stuff is remedial. If you're a NASA person, this stuff is also remedial. So, but maybe there's some crossover where if you're unfamiliar with, this is based on a set of slides that I gave at Embedded Linux conference this past year in Seattle. And so I'll just go, I'm going to go through a couple of things quickly because I think most people are kind of aware of it, but just this is a brief introduction of who I am. Principal software engineer at Sony. I've been there for over 20 years. I'm on the Linux Foundation Board of Directors. I run this thing called the Embedded Linux Conference. And I've been doing Linux and open source software for a long time, really long time. So I'll have the presentation up. So a few quick lessons from open source software in space. And this is the part where I feel like I'm bringing a goldfish to SeaWorld with NASA people in the room. But space is hard. It's like not just a little hard, it's really hard. Okay. And there's a bunch of lessons, I think, from open source in space. There are so many constraints. I mean, I've been doing embedded for over 30 years, and I've never had this many constraints, right? I've had low power situations. I've had, size, once Sony asked me to get the kernel and the user space down to 10 meg for a camera we were doing, which, that felt tough. But like that's still nothing compared to what the NAS people are doing. You have, and when we were talking about the radiation, the talk on radiation, that's just one of like 5 things that are like super hard about space. There's the temperature, there's the vacuum, there's the vibration. You have limits on the power, the physical size, on the weight. You have requirements in terms of performance, fault tolerance, real-time power management. Okay, and then it's extremely high cost per mission because of those, right? And also, a lot of times, how many units can you amortize that cost over? One. Okay. And so, at Sony, we're making 10 million TVs. We can take the development cost and spread it out. And, luckily we can get a TV down to a price that's affordable for a consumer. But you have this high cost, not only of design, testing, hardware launch, but then you have ongoing operations. So failure is not an option. So a lot of times in the space sector, things are over-engineered. They have to be over-engineered to make sure, there's so little chance of failure, that you're not gonna, so, and some people don't realize that's why you see these things where they say, oh, opportunity lasted like way beyond its lifespan. It's like, well, that's because it was over-engineered, right? So, it's not that we expect it to last, but like that's kind of the lifetime is kind of the minimum. But as long as it'll keep going, we'll keep grabbing science out of it. And so it's over-engineered for robustness. Space missions use lots of custom hardware. The focus of missions is specialized science or commercial tasks. That's the payload. And that's kind of where there's a lot of focus on that. Almost every payload, because it's so expensive, has unique bespoke hardware. Even if you're using something you've done in the past, there's always some spin. You're trying to learn something new, right? And even the base system, right, their technology kind of demonstrations, you're trying to learn something new, right? So some thrusters went bad, I think, on a recent moon mission, and that's because they were trying a novel thruster approach. And so every mission wants to try something new because your opportunity to go to space is, your opportunities are so limited. Oh, by the way, that's Mars Cube 1. That was a Linux mission. But things are starting to change, right? So we're actually starting to see more COTS in rockets. In particular, SpaceX rockets are using triple redundant pairs of COTS x86 processors. I thought I heard Michael say that these might be rad hard. I didn't think they were. They're solving a fault tolerance problem with redundancy, but still guaranteeing like real-time performance sufficient to manage a launch. right? So I can imagine the launch, you know, you got to be real time when you're controlling a 20-story rocket that's going to space. Um, so Starlink and Planet satellite constellations are using x86, and to my knowledge, they're using COTS processors, not rad hardened. Mars Ingenuity helicopter and the Perseverance rover and back shell used some off-the-shelf parts. They actually went to SparkFun for some of their sensors, right? So they're getting the same thing into space missions that an amateur can buy off the internet, which is pretty cool. So space is embedded in the extreme. It's embedded on steroids. But it's emblematic of all of the issues that show up throughout embedded systems that Linux has put on, right? Constraints on power, performance, real time, custom purpose devices and software. And just in general, it's hard to find people to collaborate with when you're in this unique of an environment for some parts of the stack. And I'll talk about more about that. Okay, so now that was the space part. So now this is the open source part, which is going to be remedial for a lot of people. But what defines open source? Open source is defined by the ability to use, but also to contribute to an open code base. And there are two key effects that I refer to as the open source effects. The many minds effect and the problem solver effect. And you've heard these before, right? What is the many minds effect? Well, it's that the variety of experience and skills results in better ideas. So open source strives for a meritocracy where the best ideas can win, right? And I like to compare it to light bulbs. In fact, the idea for the light bulb, it was so good that that is still used, right? When you see an animation of someone having a great idea, they put a light bulb over their head that goes off, right? And so project ideas are like light bulbs. If you have a small community, you have a small number of ideas. The bigger your community gets, the more ideas you have, and the more probability, actually a mathematical probability, that one of those ideas will be really great. Okay. And so a lot of open source is more about filtering than it is coming up with new ideas yourself. Right. Now there are, a lot of maintainers are really smart guys and they think of things themselves, but it's surprising how often an idea from somewhere else will come in and be something that can really make a big difference. In terms of bugs, this is often expressed as given enough eyeballs, all bugs are shallow. And that's just a way of saying, right, if you have enough people looking at it, they have a variety of different experiences and skills. By the way, we had the XZ backdoor. That was a very critical security bug that was caught not by a security researcher. It was caught by a guy looking at SSH performance. And so, the idea that if you get enough eyeballs out there, someone's going to catch it. And then the other effect that I think is really important in open source is what I call the problem solver effect. So problems are solved as they are encountered, but that means that the software has to come in contact with the problem space. A lot of times what happens is, particularly in commercial software development, software is developed for an individual task, does great at that task, and then it never grows or expands beyond that niche where it was created. Software is written to solve a specific problem. But with open source, because anyone can grab that code and use it for a related task, you'll see that as the software encounters that task, now someone can say, well, this does like 80% of what I want to do. I can just extend it that remaining 10% or 20%. And then that becomes a new feature. It's like an amoeba that's growing or the thing. And this is actually a virtuous cycle, right? The more problem spaces that a piece of software solves, the more users it attracts and the bigger its community gets. Okay, so over time, it's like the blob is slowly absorbing more and more things. And that is a fundamental attribute of open source, is that it solves more problems than the original author intended. Okay, but now this presents us with the paradox of embedded open source, right? So how do you build an ecosystem when your projects are unique, right? Other users don't have your use cases. They're not using your software. They don't see the bugs that you see there, and your software is not applied to other problem domains. And so the problem with that is you don't get the open source effects that we're all striving for. Um, okay, so I'm gonna address this one in possibly the most trivial way possible. I'll divide your stack. Okay, separate your stack into the custom solutions part and the shared code part. Um, and so I phrase this differently when I'm talking about commercial software, but basically all of your stack can be divided into the portion that's differentiating, the thing that's unique to your situation, and then the non-differentiating code. Okay, so the non-differentiating code, like between all of the TV manufacturers in the US, uh, does anyone buy the Sony TV over the Samsung TV because of the C library that we chose? No, they do not. Do they care which?
No, some people do.
Well, okay. Present company accepted. So there are things that do not differentiate your product for consumer electronics, but there are also things that don't need to be differentiated on your hardware, right? If you've got the board support package for a Raspberry Pi, that is going to be the same for everyone that's using a Raspberry Pi. And so it's if you're okay in terms of cost, if you're developing the entire stack, both the non-differentiating portion and the differentiating portion, that is very expensive, right? You're doing everything soup to nuts. It's much cheaper, much less expensive to share the cost of that non-differentiating software with the open source community, even with your competitors. And I say this, it was a little weird for me when I first got into consumer electronics because I would have meetings with Panasonic engineers, and we would talk about ways to improve the Linux kernel for TV sets. And it's like, it was kind of like we were in a tent on the side of a big battle that was raging in the marketplace. And the engineers from both sides were together working out, better spears and swords, which is a strange phenomenon, but it works out better for everyone. Okay, a couple more things real quick. So generalization versus specialization, right? So you all know the difference between Legos and a custom model. So this is on the right there is the parts for a model space capsule, right? Those are custom, they're specific, they're fit for purpose. So you can take Legos, you can take those spaceship pieces and make the best spaceship possible, right? Capsule that functions properly, exactly what you want it to do. With Lego pieces, you can also make a spaceship. There's one on the right there. It's kind of janky though, right? It's got rough edges because those pieces were not custom designed for that thing. So totally admittedly, a spaceship made of purely spaceship pieces is going to be better. But the Lego pieces are more more general and versatile. And so in general, open source prefers Legos. Okay, and that makes it difficult to use. The same thing though, if you translate this into technology terms, same thing is true of modern hardware, right? A modern processor has too much stuff on it. It has way more stuff than you're going to use. A mobile phone processor has, I don't know, like 14 communications channels for I2C and all this junk. You got a bunch of not dead, but unused silicon. And why is that? Because they're trying to generalize it. They're trying to make the processor as usable in as many contexts as possible. And it's crazy. This commoditization of hardware has just lowered the price, even for these super powerful processors. You could now find a processor that runs Linux that only costs 15 cents. Okay, that's insane. But when you look at how that applies to the embedded world, your embedded app is unlikely to use every IP block that's on the chip, right? And so there's a lot of waste. Well, unused capacity, I guess is a better way to put that. And that's kind of similar to those rough edges or those nubs you might see on a Lego model. Modern software stacks are the same way. Okay, so a Bravia TV has about 56 million lines of code. 80 to 90% of it is open source. So the part that Sony has to work on for the TV is much smaller than the entire stack, and we're getting our software from all kinds of different places, from suppliers. Google is one of our suppliers, MediaTek, and we can focus on the part that the consumers care about. But it also means that we've got a lot of code in there that we're not using. And so to some degree, we're overbuilding, right? So does the Bravia TV need all that code? Does it need 56 million lines of code? No. If we were to spend, 100 man years, we could really carve that down and reduce the amount of hardware we needed to support it, or software. Same thing with an embedded product needing an SoC. Do we need everything on the SoC? No, we don't. But we can leverage the benefit of using commodity parts and open source software by not worrying so much about having it so tightly tuned. And just the relationship here is really interesting with functional safety. So there's this tension here between functional safety and this extra code, right? Because you have extra code lying around in your system. Well, how do you prove that that's not going to interfere with what's going on, right? And so those are the tensions. So there have been examples in space of this overbuilding, right? So some of the space missions, in particular, we heard about Ingenuity. There's the Asteria CubeSat and the Alto CubeSats. Those both used shell scripts, right? It's like if you were to come to me today and say, "Hey, on my satellite, I want to put like the shell scripting language." It's like, what? It's like that sounds crazy. But it turned out that for all of these missions, the ability to call out to extra functionality that had not been in the original design turned out to be really important. So they ended up using gzip, right, on Ingenuity to solve a logging problem. And it's a good thing they left gzip in the distro, right? And it's like, but that wasn't in the original design for the mission. Okay, so now, having said all that, let me talk about some tips for building an ecosystem. And I know that some of you have thought of these things already, but sometimes it's good to have a list. I'm going to talk about these five things. Increase your community, create opportunities for non-experts, improve generalization, avoid unnecessary specialization, and find allies. So increase your community. We have to actually be proactive. We have to actively invite others into our community. And we have to do something to make the community more interesting or valuable. I think this is the easiest one on the list because space already has built-in interest. There are tons of people who would love to participate in something that's going to space or something related to space just because it's so interesting. NASA has done this before, but I think gamification, right? I was looking at, I don't know if you've heard of Moonbase Alpha, which is a NASA program that lets you, run around on the moon and fix parts and stuff. And I think that type of thing, I think it'd be great to see a gamification of satellite development or a deep space probe development. Reduce barriers to participation. Obviously, we need lots of documentation and automation to help people get in really easily. You want to make it as easy as possible for people to start participating. And one of the really key things is a lot of times an open source project will focus on, well, how do we get more contributors? It's like, well, no, that's the people who are going to contribute to your project are people who have used your project, right? No one comes in blank slate, not being a user of your project and contribute something, right? So they have, in order for a developer or a user to contribute a bug fix, they have to have seen the bug, right? So contributors always come from users, and it's about, I would estimate, it's about 100 to 1. Need about 100 developers.
Yeah, I've been using about a 10-to-1 ratio.
Oh, no, I think it's much higher. Well, that's just, I mean, this is gut feel, right? I haven't done, but for every 100 users, one of them will do something that will contribute to the project. So you really,
That's high.
you think that, you think it,
Maybe higher than that.
you think it's higher, like maybe 1,000 to 1 or something? I don't know.
Yeah,
Well, it depends on,
the number of trace command users I have and how many people actually contribute, it varies.
So I guess it depends where.
it depends on, yeah, for the kernel scheduler, it's probably like 10,000 to 1. But
Or, I mean,
or a billion, yeah. Yeah, how many people are using the Linux scheduler? Probably on the planet right now, probably about 3 billion people.
yeah.
And how many are contributing? 3. So anyway, but the idea here is that you need to get users first. Okay, so a lot of people try to short circuit that and go right to developers. But you got to get, once people are using your software, you got them hooked, they're interested, they're playing around with it. And then they see something that they think, oh, well, that could be better. I could fix that. So that's important, is just the size of your contributor pool. Create opportunities for contribution by non-experts. Okay, there's a lot of, everybody focuses on the last item on this list, which is code. It's like, can we get someone to donate some code? It's like, well, that's great, but to run a successful open source project, it requires so much more than that. And there's a lot of value. Just the usage reports. This is something I talk about all the time, is Sony engineers, they're so hesitant to get on the mailing list sometimes. And it's like, no, just go out and tell people how you're using the kernel. Tell them that you saw something weird happen, or tell them that, like, we wanted to put our display chip on the SPI bus. And it's like, why would you do that? It's like, but if nobody upstream knows that you have that requirement, they can't help you out. And so usage reports, even, tell people how you're using it, or allow people to tell you how they're using it. Give bug reports, infrastructure management. One of the craziest things I ever did was I just helped build a wiki for this one developer, just because he was a friend of mine who was doing what was it? Can't remember the chipset. It was a Super Hitachi. This is way back in the day. So I just became the wiki manager for Super Hitachi, and it's like, I didn't know anything about the chipset, but I helped the project out. He was very grateful. And you always need tons of people to really fill out a project. And so it's important to kind of figure out, kind of intentionally create opportunities for non-experts. GitHub has this new tag for bugs, which is good first bug, good first issue. Yeah, which is, if you use those, it's helpful. Improve generalization. Okay, this is this is me brainstorming. I'm not recommending it, but it's like, okay, extend existing mechanisms rather than add new ones. Okay, so we were talking about CFS yesterday, which has its own internal message bus, right? So which means it adds, the 1,000th message bus to the Linux ecosystem, right?
Not just because it uses Linux, but it's all.
Well, I know. And I completely understand, right? So you're targeting an RTOS where you have to provide all your own stuff. The same thing with F prime. F prime, you goes bare metal, RTOS, Linux. So they're providing a bunch of services. And again, I don't even know if this is a good idea or not, but I'm just saying, if you have the opportunity, try to get onto the piece of technology that everybody else is also working on, right? So this is a good example of this is Binder with Android. Android has this janky IPC between Android threads. It took them 12 years to get it kind of integrated into the kernel. And it's like, it would have been faster if you had taken the features you needed and slapped them onto an existing Linux IPC. And again, I'm not saying I'm not making a recommendation, because you guys are the experts, and there are other considerations, but just, and then the other half of that equation is make sure your contributions handle other people's use cases, right? Don't just look at your own use cases. When other people start using your software, that's when the open source effects start kicking in. Avoid unnecessary specialization. We've heard this all over the place. This is basically COTS, right? So if you use the same hardware that other people are using, a Raspberry Pi or a BeagleBone, right? Do you even have to write a BSP for the Raspberry Pi? No, because there's like millions of people who are focused on that already. Same thing with subsystems and software technologies. And right, so if okay, this may seem trivial and obvious, and maybe the whole presentation is, but it's like if you're gonna do a scripting language in space, don't write a new one. Okay, there's enough scripting languages in the world. We got Python, we got shell scripts, so try to, if you have to move over something from some, internal scripting language you've written to Python, it'll be okay and you'll be better for it.
How big is the Python distro?
Well, MicroPython, you can get down to about 1.5 meg. So I don't, again, this rubs up against those constraints that we're talking about. Space is so constrained that some of these things are not options, but there are, and you might be able to even get it smaller. So, well, okay, so I don't know anything about CFS. So your presentation was the first time I've actually watched a presentation on CFS, except I've read about it, right? If I haven't looked at the code. But one thing I thought would be really fun would be to rewrite CFS as shell scripts.
Oh,
But no,
I would much rather see it in Zephyr, sorry.
well, yeah. No. No, and and you can in your mind, you can go, I can think of like 100 reasons why that's a bad idea. But for me, rewriting as a shell script would be like, teach me it like inside and out. And so I rewrote Git in Python one time just because I wanted to understand Git. And so anyway, last thing on this slide is don't over reduce, right? So leave stuff in the distribution, even if you don't think you're going to use it immediately. Don't spend like a year stripping everything down. And so I don't know, ship with more than what the absolute minimum you need, especially if you've got some margin, right? You don't need to go crazy on the margins. Well, I don't know, again, it's the goldfish and SeaWorld thing. You guys know better than me what your requirements are. Okay, and this is probably the most important slide. Find technical allies. Find people who care about the same issues you care about and work with them. And oftentimes it's not who you expect, right? So when I go out and I try to do something in the Linux kernel, I often expect that I'm going to be meeting with LG engineers or Samsung engineers or Vizio or the other TV manufacturers, or the other camera manufacturers, or whatever some product I'm working on. But like if you're worried about system size, right? It turns out that the security researchers are also interested in system size because they're reducing the attack surface. And so you've got a whole bunch of people who are looking at the issues of how do we carve up, how do we minimize the amount of code that's getting shipped? But yes.
I thought about the same thing also yesterday. We are talking about safety. We were talking so much about bit flips, memory issues. And when I heard this radiation part, I thought there's so many things which are like you need to address and you have addressed, and you see Linux is in space and you treat a lot of potential errors where the safety community talks months over like, oh, what is when this bit flip happens? Like it's a rare case, right? It's not happening most likely in the normal use case in the car, but it's like, oh, when it happens, it can destroy all the things. And like, okay, but you know that it will happen in space and you need to find a countermeasure for it on a system level. And
Right.
It's not that you're creating new hardware for it or saying, okay, yeah, it's definitely, I need to take another access. So you really
Right.
cross.
Yeah, no, and that's why I have fault tolerance on here. And in fact, I thought the pairing of like the Space Initiative with ELISA is really, really good. Because the overlap of concerns is really high. But I mean, like for fault tolerance, it turns out the banking people care a lot about fault tolerance.
Yeah.
And they want, like, you know, like into the 5 nines or 6 nines or 7 nines of reliability as well. And so again, it's not always who you expect it to be. In terms of low power usage, right? It's obvious, mobile phone, right? Everybody wants their phone to last longer. IoT people want their devices in the field to last longer. But it turned out that the data center people, right? They're running they have gigawatts of power. They're now talking about building nuclear plants specifically to power data centers, and they just have the same level of concern about power usage, which is like really interesting, right? And so I'm just saying, you know, you need to look for those people who you may not assume have the same interests, but actually technically that, you know, they do. And one example of this in terms of technical allies. So just recently this fall, I've started a boot time special interest group. And you know, I just put out some things on LinkedIn and on kernel mailing lists and stuff. And I was surprised by the range of people, you know, so the obvious people showed up, like the automotive people, and the consumer electronics, desktop and mobile. But then like the cloud server guys, turns out that they don't like the VMs to come up slow. They want you know, they're making money as long as that VM is off. And the same thing for supercomputers and stuff. And so also I encountered a lot of developers that had limited kernel experience, but wanted to help out in some way. So one of the things I did was I created some automated tools that even non-experts can run, and I have a wiki where people can contribute data and docs. But anyway, that's just a single example of a technical area where you can find an ally and make good progress. And I think that is one of the keys to creating a good ecosystem and integrating with the existing ecosystems. I think I am super excited about this space grade Linux working group. I think this is a NASA photo. It's public domain. There are so many exciting things. Space has never. I feel like we're on the golden age of a new era of space exploration. Launch costs are coming down. Exciting technologies are happening. There's going to be like 3 lunar missions in the next 3 months, which is just mind-boggling. You know, so it couldn't be a better time to you know, get involved and work on advancing, you know, the role of open source in the space sector. And so that's it.
Thank you.
You went
over, but the next speaker isn't online, so I was letting you go.
Okay, all right. Sorry about that.
You can have questions until we'll see if we can chat. We can have questions for a few more minutes if people have questions, want to talk about anything you want to ask.
One area contributors publishers actually. We're finding is we have contributors who aren't contributing directly, but they're helping out.
Oh, yeah.
To expand the user base, we have to have user
Coach.
finds a problem, and then some non-maintainer that helps them solve.
Yeah.
What I find is often those around weird sites like Reddit.
Yeah. No, and that is really helpful. In fact, one of the secrets, there's a company that does upstreaming work and for a maintainer, and they said the best thing they can do in order to get their stuff maintained is to go answer other people's questions and do code review, so the maintainer has more time. And so I think you're exactly right. There's an unseen contribution when people provide the support role for other users. Oh, there's a question. Okay, Ivan.
So I have a couple of questions, and I want to, or a couple of comments, and I want to hear your thoughts and maybe other people's thoughts as well. One of them is, in terms of getting people to contribute, I tried really hard to lower the bar to contribution, to tell people just open issues, tell me what's wrong with when you try to install it. Still, nothing seems to motivate people as much as money. There's a cash prize for contributing to an open source project. We get tens of contributions in a couple of months. There's a lot of organizations that are using open source, a lot of them commercially. And yet we don't see a lot of mechanisms for people to work on open source paid or to have economic resources to finance contributions. What can we
Yeah,
do about that?
Well, this is why we try to get a virtuous cycle going between companies being able to make profits and pay people salaries that they can put things into open source. The challenge I've found personally with pay for things is they do a thing and then they walk away, and so there's no maintenance. And realistically, for open source to work, you have to keep engagement over time. So self-motivation is usually the best way, even though it takes longer to build.
Yeah.
That's my perception.
And my,
Yeah.
my only experience too from maintaining a few things, the problem comes to the users or someone that you want to contribute. Now, it depends on how much they are interested in. Sometimes it's just a tool for them to get something else done. And if it's just a tool to get something else done, they're going to expect spend the minimal amount of time, because it's just like, oh, it's an overhead to work on this. It's just, I'm using this tool. Great, thank you for it. But a lot of people don't, like you said, yeah, you pay them, it gives them incentive to do that. But they're, once you've done, stop paying them, they're going to disappear again. They're only there. But I heard Kate, I heard you say, you know, as soon as they stop paying, they're gone. That's true. So it's basically, you need someone that wants to, that enjoys the project. The Linux kernel luckily is so popular because it's fun to, I mean, kind of like you come to conferences if you're a Linux kernel developer, you get jobs. I mean, it's a unique project because there's prestige to it. If your project is just something that's kind of side up, it's really hard to get developers. Now, what I do is usually whenever someone's, I actually reach out and engage when someone says, hey, I got this problem. I say, good. Can you look at this? Try to like encourage them to kind of solve it for me or something. That actually worked a little bit. And then sometimes like, then I get a patch from them every so often because they broke the barrier. So it really is that scratching of the itch, you know, doing it because they want to do it. If you try to pay them or get some other way, it's going to be very, it will work. But
What works well is if you encourage them enough, and then they get enough visibility that they can use that to negotiate other jobs in different areas.
Yes.
Like, we know a lot of people in the kernel who basically go from company to company, and one of the conditions when they join the companies, they can still keep working in the kernel, partially on their own time, but also, you know, partially as part of their day job.
Yeah.
And I think that gives developers a certain amount of resilience in the economy as well, which is also an attractive feature. So by being able to leverage these things over time, and we're seeing that the Linux was my model for Zephyr.
Yeah.
And we're seeing this now start with, I've seen Zephyr developers go from like across three companies in the last 5 years.
another thing, actually, Mark, another thing, since when I joined VMware, my job wasn't actually doing development. My job at VMware was to change the attitude of the company on how they work with open source projects. And one thing that I would still like to advocate to companies that are not Red Hat is that, you know, Dirk Hondo always said, free software is not free. It might not be paying for it, but there's other costs involved. You should be dedicating engineers on contributing, and the more that you can push upstream, the less burden you have to maintain it. And but it still has costs. So we have to teach companies. Seems like companies have no problem with a contract with Microsoft to say, oh, I'll just pay you a maintenance fee. And then they'll just use an open source project and say, oh, it's free. We'll do that. Not realize, and then they're like, well, wait, we have these issues with it. Now we have to spend all this time and resources. Well, they should have budgeted that up front. So it really is.
One of them, so one of them has a fixed, clear cost. You can easily budget for it. It's like, this is the price of the license. That's it. I can do the math. But the other is unclear, it's undefined. How many issues am I going to find, and how many resources do I need to dedicate to fixing those? It's really hard to do the math ahead because you don't know what the issues are. You don't know what you don't know.
Actually, that's a good comment. That should be something for open source summit where you have awesome. That's an OSPO topic.
It is.
That's an awesome topic.
Yeah, it's
Yeah.
an awesome topic. The other thing too is like the metrics for community management and monitoring community. There's a lot of standards coming up, like the Chaos Project in particular is trying to define common ways of assessing and risk. They're coming up with guides and things like that for how communities can monitor themselves. So you can turn it into numbers too, but the heart is basically getting developers, and quite, to your point, getting more than the developers, getting other people who actually care about the project, who are not contributing code, really does make it possible. Like, for instance, I'm not a developer, guys, anymore. I used to in my past, but I'm not contributed a single line to Linux kernel. But I think I've had some degree of impact.
Yeah, no, you
Yeah.
definitely have.
Yeah.
And one thing we did at VMware was when we worked with open source projects, we would actually dedicate, well, for these projects, you have to like dedicate a small amount, like you just say a percentage. So it's not a cost, it's just a percentage of time that needs to be dedicated that the engineer can spend fixing something, communicating something. So basically, it's more of a time budget than actually a monetary budget.
Yeah, the time is important.
Yeah, well, and just to circle back a little bit, I really think the passion comes first, right? It's money is a particular type of incentive, but I've actually done presentations where I talk about all the other incentives, the reasons people do open source. And money is probably the least effective at getting long-term kind of engagement. It's the passion is much more effective. I don't know how you develop passion. I think going back to one of the points in the presentation, it's users. So if you have someone who's a longtime user, there's just, you know, over the course of their experience with the software, there's a chance that they'll like turn into a contributor. And so,
NASA's got a history of finding passionate people.
Yeah,
Yeah.
exactly.
That's
Yeah.
cool.
well, yeah, yeah, NASA's at a big advantage.
So I don't know, Ivan, did we answer your question a bit?
It's
A
good
bit,
discussion.
yeah. It seems like it's still like it's a big question. There's
Yeah,
there's a lot to be discussed. Yeah, but yeah, it helped. I do have another, but I don't know if we have time. I don't know if the
Yeah,
other
we
speaker
do.
is ready.
The next speaker was a virtual one and we haven't managed to see his signs of him yet, so we're just continuing on and then we'll take the break.
Okay.
Yeah.
So go for it,
So
Ivan.
this is again just something that I've encountered, which is that sometimes, personally at NASA, I've seen resistance to using open source, and I've seen projects that they'd rather build in-house than rely on open source technology. Is that there's also a fear of, perhaps by people who are not used to it, I guess that's my take. There's a fear of using open source libraries. And I don't know if it comes from the possibility of the library becoming unmaintained, the possibility of bugs not being fixed or not having someone who could fix them, or cybersecurity issues. In the NPR 7150, in the last edition, we now have cybersecurity requirements, which includes understanding who is participating in the project, who is contributing, where are they from, what are their interests, what do we know about them, right? So yeah, there's in organizations where things are critical, safety critical, there's a resistance to adopting open source, and I don't know how to fix it.
Yeah. So, yeah, let me agree with you and toss out a couple ideas. So I think one of the biggest issues that I see, including inside Sony, is loss of control. They don't feel like they have control. You know, you don't have control over the release cycles. You don't really have control of the acceptance rate of your upstream patches, right? And there are issues that come up. I mean, it's not, these are not imaginary issues, right? So I mean, there is so the concern is justified, but at the same time, I think there's also a severe underestimation of the technology that's already available. And it's like problems have been solved by some of the smartest people in the world. And like, you know, it's like, do you really want to try and rebuild that in-house yourself?
Actually, okay, I'm going to directly answer the question, and especially this is something we had in VMware about quality of it. We actually had this huge matrix of every single open source project we used in the company. I mean, it was thousands. And we had a rating, like from a 1 to 10 rating on the quality. Is it a risk? And we actually put in how many developers are actively maintaining it. What's the license? So we had a huge matrix on it. So we knew we could do
risk analysis. Things that were very questionable, we tried not to use or move to something else, things that we found reliable. And now here's another thing is like say, well, like afraid that, say people stop being supported. Guess what? If you have a proprietary product that suddenly the company goes under, you are now completely unsupported. We had a few cases like that at almost every company I've worked for, besides except for Red Hat, where the product or like we were relying on someone that the company just stopped making that product and say, we're not going to support it anymore. And now we were like, we don't have the source code, we have nothing. We're relying on old code and we're trying to passively switch. to
At
something.
least with open source, you got the code.
Yes, and at least saying worse comes to worse, we bring it in-house.
Yeah, one extra comment too, like in the case of NASA, maybe there's some open source project that exists that they want to use that has like one maintainer, so it's slightly a risk, but that one maintainer is Russian. They just can't use it, so they have to read it. Right? Maybe that person is the foremost expert in whatever that technology is, but unfortunately, they can't.
Okay, so it looks like we have Naresh online now.
Okay,
And so if you want to stop sharing, we can turn it over and I think